So here is another question in thermal energy transfer which requires understanding of lateral heat of fusion, right? Especially in the case of ice. So let's look at this and see if we can solve this. So surface of a pond of area 20 meters square, right? So pretty large area, 20 meters square. Okay. It's covered by ice of uniform thickness 6 centimeters. So it has some ice which has a thickness 6 centimeter, which is going to be simply 6 divided by 100 meters. Okay. So effectively we will be able to compute the volume, right? The temperature of the ice is -5 degrees Celsius. Calculate how much energy is required to melt this amount of ice into water at 0 degrees Celsius, right? So the ice has to melt, and again at 0 degrees Celsius, right? So it will have basically two parts. So first, the ice which is at 5 degrees Celsius, right, has to come to 0 degrees Celsius, and then the phase transformation has to happen, which means it has to melt, okay, there, and the temperature will remain 0 degrees Celsius, right? So how much energy total required? Energy required first to bring my ice which is at -5 degrees Celsius to 0 degrees Celsius, plus the energy required to melt the ice which is there, okay, and that much energy will be required. For that, first thing first, we are going to need the mass of the ice, okay. The mass of the ice we can simply compute by the volume of the ice multiplied by the density, and density is given 900 kilogram per meter cube. So let's find the volume. Volume is going to be this area plus multiplied by the thickness, right? So 20 meter square multiplied by the thickness, which is 500, and that is going to be in the meter cube. So when you do the maths, it is going to be 1.2 meter cube, right? So that's our volume multiplied by the density, which is 900 kilogram per meter cube. We'll end up with how much ice? 1080 kilogram of ice. I expected quite a large area, so large amount of ice, roughly around 1080 kilograms, right? So this is going to melt. Before it melts, it has to decrease its temperature from 5 degrees to 0. So for that, we are going to use the mass into the specific heat capacity of the ice, which is happen to be 2100, right? 2100 multiplied by 5 degrees, okay, and then the total mass, which is 1080, multiplied by latent heat of fusion of the ice, which is 334 kilojoules, or this much, okay. So this much is the energy required, simply, okay. So we do the maths, and this is going to be equal to, we can now do this maths. So this seems to be large number. Let's convert everything into kilojoules for the ease, okay. So this is 30 will go, so basically 108 into 21 into 5 kilojoules plus 1080 into 334 kilojoules, right? And when you do the maths, it becomes 372 into 10 to the power 6 joules, right? And that will be equal to 3.72 into 10 to the power 6 joules. And that much energy is required basically to convert the ice, which is 20 meter square in area and 6 centimeter thick, to convert into water at 0 degrees Celsius, right? So important point is that first the ice has to come from -5 to 0 and then melt, okay. So this is a combination of, again, the specific heat capacity problem and the latent heat capacity.